All right, let's get right into it. Today, we're going under the hood of one of the biggest forces shaping our world, artificial intelligence. We're not just going to talk about what it does, but how these things actually learn. Let's dive in.
So chances are you've already used AI today. Maybe you asked ChatGPT a question or used a navigation app. But using it is one thing. Understanding what's happening behind the screen is something else entirely. And to really get a handle on it, we need to look past the chat window and see how these systems actually think.
So to build that understanding, we've got to start with a solid foundation. First things first, what do we really mean when we throw around the term AI?
At its absolute core, AI is just this massive, broad field of science all about making machines intelligent. But here's the crucial part. It's not about making them think exactly like us, it's about getting them to achieve intelligent results, no matter how they get there. It's really all about the outcome, not necessarily the thought process.
Now, AI isn't just one single thing. A really helpful way to think about it is like a set of those Russian nesting dolls. There's a few key layers inside that you've probably heard of, and they all fit together.
So that biggest, outermost doll, that's artificial intelligence, the whole shebang. You open that up, and inside you find machine learning. This is a specific way of doing AI where we let machines learn from data. And then, at the very, very center, you find deep learning, which is this super powerful type of machine learning that uses these complex neural networks, which are actually inspired by the way our own brains are structured. This little doll at the core, it's what's powering so many of the most advanced tools we use today.
And that right there, that illustrates a massive shift in thinking. See, the old way of doing AI was all rule-based. Programmers had to sit down and manually type out every single instruction. It was incredibly tedious. But machine learning completely flips that on its head. Instead of giving the machine rules, we just feed it tons and tons of data and let it figure out the patterns and the rules all on its own. It's a real game changer.
Okay, so if machines are learning from data, how do they actually pull that off? Well, you can think of it like there are 3 main recipes in the machine learning cookbook, and each one is used for a different kind of dish.
So the 3 big ones are supervised, unsupervised, and reinforcement learning. Supervised learning is kind of like being a student with a teacher. Think about your email learning to spot spam, because you've already marked thousands of emails as spam. You've given it labeled examples. Unsupervised learning, on the other hand, is more like being a detective, just looking for clues in a pile of evidence. For example, a streaming service might group you with other users who watch the same weird sci-fi shows without anyone telling it to look for sci-fi fans. And finally, reinforcement learning is all about learning by doing, pure trial and error. This is like an AI getting really good at a video game by getting points for good moves and losing points for bad ones.
Now, each of those is a totally fascinating field on its own, but to really get a gut feeling for how this works, we're going to zoom in on the most common one of all, supervised learning. Let's break it down with a really simple, practical example. Let's imagine we want to teach a machine to sort fruit. Simple enough, right? To do this, we're going to use a classic algorithm called K-nearest neighbors, or KNN. And the reason it's so great for explaining this stuff is that it works on a principle that is just super intuitive to us humans. Basically, that similar things tend to hang out together. Right, so the whole idea boils down to this. We just instinctively know that, apples are more similar to other apples than they are to bananas. The algorithm is just applying that exact same logic, but it's using data to do it. It's all about measuring similarity. So how does a machine measure similarity? Well, it takes the features of each fruit, things you can measure, like its weight, its width, its height, and it plots them as a single point on a graph. And what happens is, fruits that have similar features naturally start to form little clusters in this imaginary space. Okay, so picture it. Our graph is filled with all the known fruits we have, all nicely labeled. Now comes the fun part. We introduce a brand new, totally unknown piece of fruit. We measure its features and we place its little dot on the graph. The big question for the algorithm is, what is it? And the logic here is just beautifully simple. The algorithm looks at the K nearest neighbors. K is just a number we get to pick, like, say, 3 or 5, and it represents how many neighbors we're going to ask for their opinion. Those neighbors then basically get to vote on what they think the new fruit is. For our example, let's keep it super simple and just set K to 1. We'll just ask the single closest neighbor. So the algorithm looks around, and it sees that the single closest, already labeled dot on the graph is an apple. And just like that, it classifies our new fruit as an apple. There it is! The machine has successfully learned, not because we wrote a bunch of rules about what an apple looks like, but because it found a pattern in the data all by itself.
This simple little fruit sorter actually reveals an incredibly powerful idea. And as machines get better and better and better at this kind of pattern recognition, it kind of forces us to ask a much deeper question. So what then makes human learning so special?
You see, an AI is brilliant at spotting patterns and data points. But what really separates us is our ability to understand things deeply with context. The algorithm classifies the fruit as an apple because the data points are close together. But we understand what an apple is. We know its taste, its smell, its place in stories and culture. And that leaves us with a really big question to chew on. As artificial intelligence gets unbelievably good at calculating answers and applying knowledge, what does that mean for us? What are the uniquely human skills, like wisdom and creativity and deep critical thinking, that we need to focus on in this new age? Something to think about. Thanks for digging into this with me.